Hello guys, welcome to our class. This is Nobleman Science Tutors Online, and for our class for today we are going to be looking at the principles of flotation. So we are going to look at Archimedes principle and then the principle of flotation. Alright, so you are welcome. As I've always said, please get your writing materials ready so that we can go straight to the class. This is Nobleman Science Tutors Online. I remain notable Michael, and then you can reach us via the WhatsApp number that is showing right on your screen. Please, if you have not subscribed, please subscribe to this channel. Click on the notification bell so that when we upload a new video, YouTube will notify you. You can also invite your friends to come and enjoy this wonderful physics class that is online. Okay, so please just get your writing materials ready. Please, if you like what we are doing, give us a like, give us a thumbs up, and also give us positive comments. That's okay. We are putting on a lot of effort to produce this material. So we welcome you to the class for today. Let's go straight to our class if you are ready. Okay. So our class for today, we are looking at equilibrium of bodies in liquids, and we are going to look at Archimedes principle and the principle of flotation. Okay, so this is equilibrium of bodies in liquids. The equilibrium of bodies in liquid is governed by the Archimedes principle and the principle of flotation. If you know the story of Archimedes, okay, Archimedes was the one that actually discovered this Archimedes principle, and the principle states that when an object is completely or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid displaced by the object. Okay, so what this simply means is that if this experiment can actually be carried out, okay, so if you have maybe a container, a bowl that is you can fill to the brim, and then you now take the weight of that object, right? Take the weight of the object in air. That is when you have not immersed inside the fluid or inside the water. Take the weight, use a weighing scale, take the weight of that object. Then now put that object inside the filled brim, and then maybe try to make a provision where you can collect all the water that will spill out as you immerse that object inside the water. If you are able to collect all the water and you weigh it, you'll find out that the weight of the fluid or the weight of the objects in air is equal to the weight of the fluid that is displaced, or is equal to the weight that you collected. That is the weight of the liquid that you collected. Okay, so this is what Archimedes was able to discover, and it actually helped to explain the principle of flotation, why objects float in water, okay, or why objects float in fluids, because fluid has to do with both water and air or gas as the case may be. So Archimedes principle states that when an object is completely or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid displayed by the object. Or when an object is immersed in a fluid, it displaces a volume of fluid equal to the volume of the object. So when a body is completely or partially immersed in the liquid such as water, it experiences an upward force which tends to make it weigh less. So, and this is actually true. If you put an object in, if assuming you are fetching water from a well, or if you are dragging something from inside the water, you find out that the object will weigh less, but immediately you bring it, it will weigh less. Immediately you bring it from the water, you experience the real weight of the object. So objects immersed in water or in fluid, they actually weigh less. So it experiences an upward force, right, that tend to make the object to weigh less. And this upward force that tend to make the object to weigh less is called upthrust. So upthrust is a force that tends to push a body upward when it is immersed in a fluid or in air. It is the upthrust that tends to push the body upward, and this force that the object experiences is called upthrust. Okay, so upthrust on an object in a fluid is equals to the weight of the object in air minus weight of object in fluid, we know that the weight of the object in air is always greater than the weight of the object in the fluid. And that is what I have stated here. Upthrust is weight in air minus weight in fluid. Weight in fluid is less than weight in air. Is that okay? So when you are talking about weight, upthrust is equals to weight of displaced fluid or weight of fluid displaced. So when you are talking about weight, we know that weight has to do with force, right? So from this we can derive an equation for upthrust, that if U represent upthrust, so upthrust is equals to weight displaced, okay, weight of fluid displaced, and weight we said is equals to force. So and force is the same thing as mass of fluid times g. G is acceleration due to gravity. Now we know from the definition of density, density is equals to mass over volume. So mass is equals to what? Density times volume. So we can substitute this equation now into this position of mass to have that upthrust is equals to density times volume times acceleration due to gravity. Okay, so upthrust is equals to density times volume times acceleration due to gravity. Is that okay? So this is the definition of upthrust, and this is the formula for upthrust. I hope that one is clear. Okay, so I hope this is clear. Is that okay? So upthrust is density times volume times acceleration due to gravity. All right. So let's go to flotation. Okay, so this is principle of flotation. The principle of flotation, just like Archimedes principle, states that an object will float in a fluid, liquid or gas when the upthrust exerted upon it by the fluid in which it floats equals the weight of the object. So what this simply means is that a floating body will displace its own weight of the fluid in which it floats. Okay, so this is just like a complementary principle to the Archimedes principle, right? A floating body will displace its own weight of the fluid in which it floats. So a body will float in a fluid if its density is less than density of the fluid. That is why balloon float in air. A balloon will float because the air in the balloon is less than the atmospheric air. Alright? The air in the balloon is less dense than the density of the atmospheric air, and also the weight is equal to the weight of the air displaced or upthrust of the air on the balloon. So it is this same principle that makes a ship to float in water. Okay, so it is the principle of flotation that makes ships to float in water. A ship will displace its own weight of the water in which it floats, and ships, they are less dense than the liquid in which they float. Okay, so a body will float when its weight is in equilibrium with the upthrust acting upon upwards. Alright, so this is the principle of flotation. Okay, so having gotten this background information, we are going to be discussing relative density. Density and relative density. Okay, so density is defined as the mass per unit volume of the material, and the unit of density is kilogram per meter cube. Okay, so mathematically stated, this is density, and I'm sure you're familiar with this equation. Density is equals to mass over volume. We just make sure that in the first slide or so. Okay, so relative density of a substance is a ratio. Relative density is the ratio of the mass or weight of any volume of the substance to the mass or weight of an equal volume of water. So if you want to find the density of solids or liquid, these are basically the formulas that we use. Relative density of a solid is mass of the substance in air all over mass of equal volume of water, or weight of substance all over weight of equal volume of water, or weight of object in air all over weight of equal volume of water. So as the case may be, you can use any of this formula to find the relative density of a solid. While the relative density of a liquid is equal to upthrust of object in liquid all over upthrust of object in water, or apparent loss or weight of a solid in liquid all over apparent loss or weight of the same solid in water. So know that when you want to find relative density, you find the mass of the object in air all over mass of the object in liquid or water. Depends on which equation that you want to use. So for us to get a better understanding of this, we'll have to solve some problems right away. Okay. Okay, so this is a question that we need to look at and then solve. Say an object, the question says that an object weighs 0.3 Newton in air, 0.25 Newton when fully immersed in water, and 0.27 Newton when fully immersed in a liquid. So it says calculate its loss in weight in water, calculate its relative density, then calculate the relative density of the liquid. So here you are asked to calculate the relative density of the solid and of the object, and also the relative density of the liquid, and then the loss in weight when it is immersed in water. So for you to solve this problem, first of all, you take down the information that you are giving. Okay, so you are giving that weight in air, which I'm going to represent as WA, is given to you to be equals to 0.3 Newton. Then you are given that weight in water. I will use that weight in water W is given to us to be 0.25 Newton. And then weight in liquid, I'll put WL is equals to 0.27 Newton. So these are the informations that are given to you. Is that okay? So the upthrust on this object now is the apparent loss in weight. So the loss in weight, the first part of the equation, the loss in weight of the object is equals to weight in air minus weight in water. Okay, so and this is the upthrust on the object. So this is equals to 0.3 minus 0.25 Newton, and when you do that subtraction, you are going to have 0.05 Newton. Okay, so this is the loss in weight of the object. Then the B part of the equation is that you find the relative density of the solid. Okay, so for you to find the relative density of the solid, you write that equation as weight in loss in weight, or weight in air all over upthrust, or all over loss in weight. Remember I said that the loss in weight is equals to the upthrust. Okay, so the loss in weight, the weight in air of the object is 0.3, and then the loss in weight is what we've gotten already before, and that is 0.05. Okay, so by the time you work this out, you are going to have that the relative density of the solid is equals to 6. So if you do that calculation, you are going to have 6 as relative density. Don't forget that relative density doesn't have a unit. Okay, so that is the second part of this equation. Weight in air all over loss in weight, right? Or all over weight in water, loss in weight in water. Then C, say calculate the relative density of the liquid. The relative density of the liquid, represented as RON, is equals to upthrust in liquid all over upthrust in water. So upthrust in water is what we have already calculated to be this. So upthrust in liquid, upthrust in liquid, upthrust in liquid, first of all find that one. Upthrust in liquid is equals to weight in air 0.3 minus 0.27. This will give you your upthrust in liquid. The upthrust in water is what we have already calculated before, 0.3 minus 0.25. Okay, so this will give you so when you do this, you have this will give you 0.03, and this will also give you 0.05. Okay, so this is what you will have. Now you now say that relative density of the liquid is equals to upthrust in liquid is 0.03. 0.03. Upthrust in water is 0.05. So by the time you divide that out, you are going to have 0.6. So this is equals to the relative density of the liquids. Okay, so this is how to apply those equations that we called before to solve problems on relative density, upthrust. So in case you have a question on relative density, on upthrust, upthrust is weight in air minus weight in water. All right, weight in air minus weight in water, or weight in air minus weight in air liquids, as the case may be. Okay, so this is how to apply this equation. We'll try to solve another problem too, so that we still get. Okay, so this is another question. An object weighs 10 Newton in air, 7 Newton in water. What is its weight when a mass in a liquid or relative density 1.5? So we have said that upthrust, or we said that relative density of the object, relative density of the object or solid is equals to apparent weight, apparent weight, okay, apparent weight in liquid all over apparent weight in water. Okay, so apparent weight in apparent weight in liquid is equals to weight in air minus weight in liquid. So weight in air is equals to 10 Newton minus the weight in liquid all over apparent weight in water is equals to 10 Newton minus weight in air. Okay, so this is what you have. So now you can put your information, because relative density is given to you to be 1.5. So you just say 1.5 is equals to 10 minus weight in liquid all over 10 minus 7.0. So you can actually work this out. So this will give us 10 minus weight in liquid all over 3. So what we are looking for is this weight in liquid. That's what we are looking for. Okay, so you can do your cross multiplication so that you have 1.5 multiplied by 3 is equals to 10 minus weight in liquid. Okay, so this gives us 4.5 equals to 10 minus weight in liquid. Okay, so for us to get the weight in liquid, subtract what you just do, make the weight in liquid the subject of formula. Okay, so this will give us weight in liquid is equals to 10 minus 4.5. So by the time you work that out, you'll have your answer readily. That gives you 5.5 Newton. 5.5 Newton. So this is also another way of using these equations to solve problems regarding that has to do with relative density and upthrust. So you can see how upthrust and relative density how they are related. Okay, I hope you are following. So let's take another question. This one says a solid weighs 5.0 Newton in air, 4.2 Newton in water, and 4.4 Newton in a liquid. Calculate the relative density of liquid Y. Calculate the relative density of liquid Y. So we said that they're giving you weight in air, gave you weight in air to be 5.0, weight in water to be 4.2 Newton. This also Newton. Then weight in liquid is given to you to be 4.4 Newton. So using our formula, we said that relative density is equals to what? Relative density of liquid is equals to apparent weight in liquid all over apparent weight in water. Okay, so we said apparent weight in liquid all over. So apparent weight in liquid is equals to weight in air minus weight in liquid all over weight in air minus weight in water. Okay, so just substitute your value to this equation. So you have 5.0 minus 4.4 all over 5.0 minus 4.2. So by the time you work that, you are going to have 0.6 all over 0.8. Okay, so when you do your division out, you have 0.75. So this is the relative density. So you can actually see that the equations are not really too hard to solve. It's just for you to have an understanding of the equation. Is that okay? So this is where we're going to stop for our class today. I'm sure we've covered a lot on this particular topic. But before we go, please, you need to solve some problems for yourself. So we're going straight now to our test your understanding page. So this is for you to test your understanding of what we have discussed so far. The first question says that a solid plastic cube of size 0.2 meter is submerged in a liquid of density 0.8 kg per meter cube. Calculate the upthrust of the liquid on the cube. Remember that we said that upthrust is equals to volume times density times G. So find the volume, multiply by the density and G, you get your upthrust. Simple and direct. I've given you the hint for that. Then this, a body weighing 10 Newton in air is partially immersed in water. it displaces water of mass 0.3 kg. What's the upthrust on the body? Fine. So this is the weight in air. Calculate the weight in water, which is the weight in water, multiply this by 10 to get the weight in water, and then you do your subtraction to get the upthrust on the body. Right? Upthrust is weight in air minus weight in water. Simple and direct. Okay, so this we are just solved now. The last problem we solve has to do with it's just like this too. So you can actually solve this problem without me giving you any hints. All right. So guys, thank you so much. We appreciate your time. But before we leave, or before I leave, please, if you have not subscribed to our channel, please, what are you waiting for? Subscribe to this channel, give us a like, give us a comment, and click on the notification bell so that whenever we upload a new lecture, YouTube will notify you. Is that okay? Please give us a good comment so that we'll continue to bring out these wonderful lectures. As I said before, this is a work in progress, and we're trying to present all the we are trying to cover the Nigerian physics curriculum, right? So we are taking it from the senior secondary school 1 down to SS3. So that's why you see that we are taking the lectures in bits so that we will not clump up and make it too large. So that's okay. So just follow us as we continue to upload new videos. Alright, so this is Normal Math Science Tutors Online. I remain Notable Michael. You can reach us via the WhatsApp number that is showing right on your screen. Thank you so much for your time. We'll see you in our next class.